Hello and welcome to an open source live code hangout. Today, we're going to try something a little bit different. We're putting the GeriLife project on hold while we have internal discussions, and I thought since it's a Friday, I'll just do something more recreational, sort of fun and exploratory. So in my spare time, I like to do a little bit of music production, and I'm really interested in synthesis, modular synthesis, or audio synthesis. And there's this really excellent project called VCV Rack. It's open source, and it's a Euro Rack modular environment simulator, I think they call it. And what does all that mean? Well, basically you have modules that are small objects that have different knobs and parameters, and they essentially will make sound or modify sound in some way or control other modules. Those are the main elements. You have signal generators, signal modifiers, and modulation sources, which are things that will sort of turn the knob for you automatically. And there's some really excellent and prominent creators in the VCV Rack community. And VCV Rack itself is open source, and there's a free version and a pro version in this stream. And generally, if I continue working with this series, I will use mostly the open source plugins. I have the VCV Rack Pro for a few features, but here's what it looks like in action. You can see some of the modules don't actually generate or modify the sound, but well, they modify it in that they can convert it to visual form. Everything's dynamic here, and the whole thing sort of sends a signal all around and eventually to your speakers or headphones. And it's just really interesting, creative, and sometimes these contraptions take a life of their own, basically. That would be what we would call the generative audio. So I've been using VCV Rack for a while to make music, but I'd like to get into the code a bit and see how some of these modules are made. There are over 3,000 modules that you can download, and almost 3,000 of them are free to use, and over 2,000 of them are open source. So you can download them, you can use them, and you can see how they work. There's whole collections of them. Surge XT is one of the premier open source collections for modular synthesis. And yeah, as you explore, you'll find your own favorites. I certainly have a few of my favorites. One I recommend checking out is Bog Audio, also Befico. Befico make these in both the hardware form and the software, and all their modules are open source. So these are emulating actual physical devices in software form. These are called hardware clones, and the whole VCV Rack project is emulating a hardware kind of paradigm for creating music. And this has a long history going back to the 50s and 60s, and a couple of major prominent branches of this family of synthesis, audio synthesis, pioneered by Bob Moog and Buchla. I can't remember Buchla's first name. Bog Audio, here we go. So these date back. Don Buchla was the pioneer of a modular synthesis rig, and is designed primarily for creating sound effects and other, I think you could sequence songs and sounds with it as well. Haven't really ever worked with the particulars of Buchla, but it's the same paradigm as the Euro Rack, which came around in the 1990s. You essentially have modules that are all have one or more responsibilities, and they can patch into one another. All this originated even in radio communications, and I think even cryptography and things. The foundations are mathematics, if you want to go deeper into that, and some of the old analog circuitry that was used in wartime communications. And in Moog Music, which no longer is owned, it's been acquired recently, but here's one of the pioneering Moog synthesizers. Again, the same idea of modules that have a particular multiple functions sometimes, and they can patch into one another. There's some, I don't know, differences. I don't know if they're subtle or significant between the Buchla and Moog approach, enough that they were coined the East Coast and West Coast approaches. But I think there's like recently a convergence of the paradigms, and Eurorack is just a different format. What they essentially are is a kind of scientific testing rigs and panels, and then with embedded electronics in the Eurorack paradigm. And so they have different sizes, the measurements. Systems aren't necessarily compatible with one another because they would use different, for example, jacks, or the module sizes would be different. The Eurorack has kind of come around as a middle ground between them. You can see this is using, I think, the 1/4-inch jacks. And I'll just take a look here at Eurorack. And you can build your own Eurorack modules, and you essentially buy a rack here, hence the name Eurorack, and it has a bunch of mount points here for screws, and you put modules in there at a certain height, and people like to share their grids. Let's see, and there's a lot of places you can buy them. I'm not super interested in the hardware aspect. It's a bit expensive for me, and I don't have a lot of space. I'm kind of trying to dematerialize, but I'm really interested in being able to explore this paradigm, and I have a lot of favorite software Eurorack modules. Bog Audio is a great collection of over 100 open source modules. Basically, it's a full Eurorack toolkit, almost everything you could need from just one. The VCV Rack itself, the core modules, there's 50 open source modules in the VCV Rack core. So even just here, you can already start exploring and creating. It's very good. I would say if you, and I agreed with a friend of mine who's kind of collaborating with me on these endeavors, sonic explorations, that we would start with VCV Core, Bog Audio, and Befico. The reason is one idea we're kicking around is making a hardware rack for some experimental stuff. And we're thinking that these Befico modules would be good to get, and if we can already experiment them in the digital form, we'll be a little bit ahead of the game without having to spend the money up front. We can start building our prototype. So that's pretty cool. Not all of the Befico models have been ported to VCV Rack, but I really appreciate that they do that, and I can see how it can be a draw to when you start to consider a hardware rack. You would already be familiar with these. They would be almost a no-brainer to buy those. I'll just mention one more that I pointed out earlier, but I've already forgotten the name. Sorry, Surge XT. 46 modules here. So if I were to go for one bonus collection in addition to Befico and Bog Audio, it would be this Surge. These are all software components, but there's a Surge XT plugin. There it was. It's a VST plugin. Sorry, VST and AU. It's what we would call just a software synthesizer. It's already wired. Everything's already wired together in this case, so you don't have to think about the wiring. You just sort of start designing your sounds. It's very powerful. It comes with a lot of presets. So if you're just looking for a synthesizer and you're not so interested in the modular part or C++ code, well, this is a great place to start. And the Surge folks are just, I guess, great fans of synthesis in general, and decided it would be awesome to break this out into VCV Rack components. I'm really grateful they did, because I've been having great fun with it on the VCV library. So this is something I'm very excited about and enjoy a lot. And so the goal today is just to learn a bit about what goes into developing one of these plugins, and can I make one? I have a few ideas that are kicking around. There's, like I mentioned, there's thousands of modules in the library. So, maybe my modules aren't so important to add, but it's a learning experience, and two, I might have some ideas that are a bit unique and can be differentiated from these other plugins, as well as the open source ones I can borrow from code, I can adapt it. So let's take a look. So what I need to do is check out, I've got an empty directory here, and I'm using this book, Developing Virtual Synthesizers with VCV Rack. It's really good, and Focal Press. And basically, it's open source. All of the code in the book is open source. So that's a really good thing for me, because I'm like pretty big into open source and big into audio synthesis as well. So I, would have bought the book probably otherwise. It's because it's really cool. But it's on Routledge. You can probably find other deals on it. I bought this one on, I don't remember actually where I bought it, but I don't think I ordered it from Routledge because the shipping is weird or something. I honestly can't remember where I bought it. But then I realized, I found out like a month or so later, they had a copy at my library, of course, which I should have checked first. But nonetheless, this is a great book. This is written for VCV Rack 1, but the recent released VCV Rack 2, or maybe it's been a little over a year now, but it's sort of recent, has some backwards compatibility. So what we learn in this book applies to the code that I'm going to write for VCV Rack 2. So I don't have like a book stand here, but basically I need to skip. One thing that this book does is puts the theory in the front part and then the practice in the back. I'm of the opinion that practice should come first and theory could come later. Once you've got a little bit of practice, the theory will start to make sense. But until you need the theory, don't put that in your way, because there's layers and 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 layers of theory you can just bog yourself down with. This book did manage to get enough theory in within 90 pages. So roughly half of the book was the theory part. I honestly, actually less than that. Because chapter 3 introduces the basics of VCV Rack, and it starts at page 74. So, not a lot of theory, but I'm just not good at math, and I know you need math for layers of DSP, but I also think that these libraries have such great abstractions that I can just create an oscillator by saying, hey, I need a sine wave or a square wave, and there's abstractions that are going to support me without myself having to have knowledge of trigonometry and things like that, which unfortunately I don't have. I think a lot of people are in that book. So I'll see how far I can get with it, but I can understand what a sine wave is. And I understand that cosine is basically in the opposite phase of a sine wave. What do you call it? They're out of phase, 90 degrees or how many degrees, I don't remember. I think that's enough for me to know how to use an oscillator, that I'd like a sine oscillator, and it is based on some trigonometric function. So what we got to do though is install some things on Linux. So I'm going to kind of run through these instructions, and we're going to have to build VCV Rack from source. So on Ubuntu, I'm going to have to install some packages. I wish I had invested in a small book stand, but we'll get by without it. So apt install. I've got git, curl. Let's see how many of those I typed correctly. All right, so there's a couple of them. zlib lg dev. Maybe that's a zlib 1g. I think so. It's a 1g. And then the other one was libjack jack2 dev. And that's jackd2. Jack Damon, I guess. So this should get us started. Some of them are already installed, and the rest of them I'll just add here. All right, so that's page number 99 in the book if you're following along at home. They've got installation instructions for Windows, Mac, and Linux. So it doesn't matter where you're coming from, you're welcome to develop VCV Rack modules. And then when we publish them, hopefully I can build for those other platforms from Linux, I don't know. But usually the VCV Rack modules I've seen support all platforms. I've not encountered any that only work on Windows or Mac or something. I've noticed that a few of the modules that are popular haven't been compiled for AMD64. So there are some issues on like newer Macs, but only like a few. I haven't encountered that much in the wild. Nonetheless, we're running Linux here. I've got the thing compiled. The installation is complete of the dependencies. Now we're going to compile. We're going to build VCV from sources. So first thing we're going to do is just clone it. I will invest in a book holder. So here we go to clone. I'm going to use, this will ask me for my password all the time. If I do that, and HTTPS is disabled. Let me just try it. Just cloning it. Well, I'm not really committing directly to the VCV Rack repository, so I don't have to worry too much. All right, now we're just going to open this directory. Second hard drive, code, audio, VCV book. Doggone, I got the wrong one. Doggone it, dognog it. Oh, whoa, Beflico is under the VCV Rack core. Wow, nice. So basically, we just need to find rack right here, pinned Pinned repository. Same thing. I guess it's good that I cloned the book code anyway, but first we're going to build Rack. And I guess I don't have to go. I can just CD into Rack. And now it looks like Rack has some submodules like dependencies, other C++ libraries, something like that. So we're going to pull those in. View dependencies. This is an interesting thing. The Rack user interface is based on SVG. I suppose I can just bring up a Rack real quick while we're waiting for this. I haven't configured my audio or anything like that, but here's my default Rack patch. These are just third-party modules, except for this one, which says VCV, and this one. But mentioned Bog Audio is like my favorite. This is Count Modula, really good stuff. Count Modula, Bog Audio, really good stuff. Impromptu is also really good. This is the best clock, my favorite clock. So it's got the base BPM clock, and then you have these ratio clocks where you can multiply or divide the clock based on, pretty arbitrary values, which gets you into like polymeters and even just doing different drum rhythms. Typically at like a hi-hat would be like, and a drum kick would be like boom, 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 tick, 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 tick. And then we got down here is MindMeld Mixmaster. This is my favorite mixer, and I'm using their 8-channel one by default with a graphical EQ, and it's also 8 channels. You can swap through them. Oh, more than 8 actually. It's up to 16, and it's got auxiliary and some group stuff because there's a MindMeld Mixmaster bigger one that has 16 channels. And this is the aux expander, so you can have a couple of sends here. So really good. This is my bass Rack. I start off with this, and then I can record directly from that, fade in and out the recordings. And this module just creates a list of everything that is in my patch. So when I upload it to Git and mainly GitHub, everything, attribution is all there. VCV Rack also keeps itself up to date. The library modules you install and the core VCV, you just kind of like say, okay, download, and it'll handle that for you. Very cool. Looks like Befco has had a new release, and then you just reload it. But let's get back to the code. It looks like all of our subdependencies have downloaded, and so now we're just going to make dep. It's going to build something. All right, we're building. So I'll just make this a little bit bigger so we can see what's going on. I don't know what's going on, but we'll at least see the progress. So that's a great sign that the book, the installation instructions so far have been up to date. All the dependencies, they were still available in the Ubuntu, the APT repository. The book was published in 2020, so it's relatively recent. I think VCV Rack 2 came out in 2022, something like that. So yeah, that's about it. I'm not used to working much with C++, and it'll be a learning journey, compiling and everything. But I guess what we're going to do is just make a hello world module that looks like this, also known as a blank. A blank is just when you have a gap in your patch and you want to fill it with something that looks nice, you can put a blank there. Or there's a gap between module. In the library, there's a lot of blanks. I'll show you some examples. For tags, there we are, tag blank. Yeah, a lot of the blanks are just like logo blanks of the, Venom is this collection of modules, and the Venom blank is the module. Seaside Modular, they're actually good. I recommend this collection. Some kind of retro looking things. This is actually a text editor you can put in there, leave yourself notes or leave notes for the other people who are opening up your patch. This vertical separator, I think it's resizable, so you can just put any arbitrary size there. And you can see some of them are just nice graphics. Usually they're logos though, or accent color. Sometimes they're just fun. Here's an ADSR envelope. This is a cool one. I'm not sure how it works, but shebang modules are fun, and it looks like this might be an animated one. This light one also is animated. Here's a good one. The Rack modules are plugged together with cables, so these cable colors can be meaningful. Not everybody uses cable colors for semantic reasons. Some people just randomly patch, and every time you put a new cable, every time you place a cable in VCV Rack, it chooses a random color from a subset of colors, but you can also specify what color you'd like it to be. And so this module might even have a shortcut key where I could say I want red cable. I use a coloring standard, so to speak, created by Omri Cohen. It says basically red is audio frequency signal, stuff you can hear. Blue is for stuff coming from clocks or that are driving this, so kind of the heartbeat blue. Triggers also, and gates. Those are sort of the heartbeats of how things open and hold, like the circulation and heart opening and vessels opening. Yellow is a special one that controls the pitch to make, you could say, musical sounds, but it doesn't have to be musical. It'll just change the pitch. Or it's called control voltage, but this can also be, green can also be used to send control voltage. So they call it CV, or volt per octave, sorry. So every volt that increases, you get a 1 octave jump, which maps really nicely. It's easy to think about. And I think two of the innovations of, I guess, Moog and maybe Buchla, but particularly Moog, uses one is the modulating, the patching paradigm. But Bob Moog particularly, I think, invented this volt per octave approach. I don't think Buchla uses a volt per octave. And the volt per octave, I think, is one of the probably most user-friendly innovations introduced by Moog. Here's some blanks. These are count module, as you can see. And some other static ones. Maybe these are animated, I don't know. A lot of different blanks. So you can style your rack as well. Generally, there's not a lot of categories of types of modules, and there's definitely some overlap, but arpeggiators help you define a series of notes or volt per octave values, or you can put in 3 volt per octave signals and it will switch between those. Attenuation is taking a signal and making it smaller, weighting it. We already looked at blanks. Chorus is an audio effect that I think takes a sound and either detunes it or offsets it, phase offsets it, so it sounds a little thicker. Clock generators are the heartbeat of the system, and clock modulators will take that heartbeat and change it, multiply or divide, for example. Compressor is a way of keeping your volume levels in a more narrow range so they don't jump. I have a really big dynamic range. You can kind of push down on the peaks, but sometimes you can push up on the quiets, so it's like upward compression or downward compression. Usually downward compression is what's supported. Controllers, I don't know. There's probably just different buttons and stuff. Yeah, kind of like interfaces, X and Y drag pad, and some sliders and things. I know color choosers, interesting. Different ways of, I think it's human interfaces. Delay is an audio effect that takes a signal and delays it by a set time or number of samples. Digital, I think, are things that are dealing with like Boolean. Not sure exactly what digital category means generally. There's a tracker plugin. If you're interested in tracker music, you can write tracker music sequences in the modular environment using this Bizet tracker. I never got into tracker style notation. I get it, and I sort of understand how it works in the columns and stuff. It just doesn't seem natural to me, but some people really do amazing work with that. Distortion, pushing the sound to the levels beyond clipping or where the wave starts to fold. They got dedicated drum plugins. I guess these are dual multi-purpose things. I don't know what dual generally means. Dynamics involves the loudness of the sound. There's just myriad effects. Envelope followers are things that can detect the level of the sound and give you a signal of how loud it was, and then you can use that signal to do things. Envelope generators will make basically a line that can be used to control things like the volume. The ADSR was an example of an envelope that we saw under the blanks. It's a particular type. It's a very common type of envelope. Envelopes are just essentially lines, but they usually start and end at 0. So all of the values, and they maybe max out at 1. So it's like 0 to 1. So it's saying go from the minimal signal to the max. It's basically multiplying the signal by 0 to 1 over some set amount of time, and then go from the maximum signal down to a hold frequency, a hold level over some amount of time, and hold that. And it looks like there's some slew on this hold that's going down, but normally this is flat. And then when I release the thing, there's a downward back to 0. So when I let off the key, in this case, they mentioned key off, it should return to the quiet, but when you hit like a piano key or something, it doesn't immediately go to quiet. So we have this fall off. Yeah, I could have done this compiling off stream, but hey, I thought, why not? Let's just take a look at the process. I don't know what to expect. So, but you can see there's lots of function and lots of categories. I've been doing streaming of VCV Rack on another channel because I mainly focus on open source on this Twitch channel and on this YouTube channel. But it would be nice to just combine the two. I don't know how interested in modular synthesis people are, so I mainly just focus on the coding part. But now at least they're converging a bit if I start coding modular synthesis, because then I could really go into depth on what some of these do and show how they work. And I didn't prepare, but I could have been doing some while we're waiting for this compiling, for example. I'll do this in another stream, but basically work with VCV Rack while we're waiting on slower things to happen. But I think we're almost compiled now. It's just checking everything. Good to go. Now that was just the dependencies. Now I need to compile Rack. Now perhaps the dependencies would take longer to compile, but now we're just going to run make. This will make Rack. Error. Blendish. C. That's what I was afraid of. I'm always a bit apprehensive about compiling stuff. Yeah, and I didn't see anything spin by, but heck, I don't know. Maybe there's a log. So I'll mention this is one thing that's slightly concerning about VCV Rack. It's open source, but if you notice, there's no issues. They've disabled the public issues, which is, still the code is open and licensed, open source license legit. Andrew Belt's the core developer, and they decided to close the issues, disable them. I don't know the exact reasons. I think there might have been some hostilities or people having higher expectations or whatever. But yeah, we can't really track what the priorities are. Yeah, and I did this. Simple fix. Linux linkers are very order dependent these days. In the make file, that needs to be that. All right. Then standalone target, standalone sources, then standalone objects. Wow. And that was in 2021 that was repaired. Why isn't that in the make file? Let's find it. Okay, so standalone target is standalone sources and standalone objects. Oh, they did fix that. Issue tracker would be nice. Build files cannot be regenerated correctly. Linked by target RT audio. The following variables used in this project, they are set to not found. Please set them, or make sure they are set and tested correctly in the CMake files. So this could be a hint that CMake couldn't find pulselib. So there we are, so there's a suggestion. So the book, I believe, omitted this dependency. Let's see if we can find something there. Alright, then I'll tell you what. While we're doing that, let's have some fun. VCV Rack. Plugging in. Got my headphones on, buddy. Yeah, and if it doesn't work, heck. I'll troubleshoot these offline, but you get the point. In order to develop VCV Rack, you have to have you have to build it from source. And then your development modules will be linked against the source, and yeah, then we'll be good to go. I see they mention all of this, and that would be cool if there was just like a, hey, copy and paste this. I don't know how to get all those installed, but at least they're listed. I hope I got everything now. All right, cool. So clone it again. Go ahead. CD Rack, and then I think at that point it was just make deps, right? No, git. Like a little bash script would be good here. Git module update recursive. And init. Well, I think we can do boom, pulling everybody in. So a lot of the dependencies that are there that were mentioned in the README, but I have to be able to compile them, and some of them I think didn't compile. Now there was probably a build.log or something that I could have looked in for errors to see which one of these couldn't build. And there might be like a README on like the development side. I don't know if there is one. Support manual. part of the way I got the VCV Pro is so that I could do some support, plugin development. So yeah, just getting a started guide would be great. But they jump straight into coding, so that's fine. That's fine. I'm not complaining. So we did that. Now we'll just make dep again and go take a nap. Actually, it's getting close to bedtime. Okay, but hey, let's see. Can I get some audio into this stream from VCV? So here, let me just check my headphones first. We'll put in a little bit of square waves. What is that? That's not a square wave. It's a sawtooth wave. Whoop, that worked. Okay, good. It was like an electric shock. I'll just turn that down for a minute. And then, so we got something there, and I'm going to put it here. And then I think I'll just add my desktop audio sound source, audio output capture. It's going to be buzzy, but at least I hope you hear something. The problem could be that I'm on ALSA, not Pulse. Problem is when I switch to Pulse, everything goes to Linux audio. Is a bit of a frustration. Yeah, it doesn't look like it's going to work. The other option is to just do a window capture. Didn't work. So the final option I'll choose, and it might be that I would need to restart OBS. But if I go to audio and I say my desktop audio and I enable that to analog stereo and I hit apply, do we get anything? Okay, and then what if I now restart VCV Rack? Just this is an experiment while we're waiting for it to compile. So if it doesn't work, it doesn't work. Now, it doesn't look like I'm going to get anything. Not with ALSA. Pulse has severe issues. I don't know what's going on there. And Jack is not running, nor is my... This is just such a mess. Why do I have to juggle 3 of them and none of them really work half the time for certain things? It's just such a frustration. That's why I really tried for many years to make music with open source stuff on Linux. It just was too much of stress and not enough creativity involved, unfortunately, for me. So I've been much more productive on other computer. But at least I have a rack here running and just making output in my speakers, and figuring out if I can stream it will be another question. But I might be able to plug in, switch to my built-in audio stereo. Okay, there we have some audio. So I just had to switch to my desktop, my built-in one, and it was stuttering. So what I did is I just increased my block size. It should increases latency, but it shouldn't affect us since I'm not recording. And I decrease the sample rate so my computer can kind of hopefully not create too many blocks. But yeah, so now we have this sound here is a saw wave. So it doesn't sound very musical right now, but we can make it kind of musical pretty easily. And that's what I usually try to do, is not to do too much like noise, but have like a balance between noise and the musicality. So for example, we could get a sequencer. I'll make a little melody here just to show you how the sequencing works. A sequence is just a series. It's like a memory. It's a stored memory. The built-in one, I'll just start with that. This one's built into VCV Rack, and each of these knobs represents a value. They're all set to 0 right now, and it's got an internal clock. You can see that's kind of like the heartbeat. And basically, I like to use blue for clock, and now we'll set the clock here. But this is 120s are usually pretty fast, so I'll go a little bit slower. And if I put this back into the speaker, this is set to a pitch right now, C4. And I can turn this knob to change that. But what we typically want to do is not want to play this knob over and over. I'm not sure how loud that is. So essentially what I can do is set some values. I'll randomize the values so just all the knobs got turned there. And I'll put this yellow cable into this volt per octave, and the range of these is so big you could hear that the octaves were all over the place. So let me go to one of my favorite sequencers, but nonetheless you could hear that it was changing. And I'll go towards a more musical sequencer. So this one it does a couple of things. One is it allows me to specify piano notes. So these 5 notes are called a pentatonic scale, And the other thing is then all the buttons that are within like a couple of octaves, so between 3 and 5. So those aren't so like, and I can change the octave range. So it's plus and minus 1 octave from middle C. I'll just randomize all these knobs. Also lets me set the pattern length. But now I can take this clock and I can just start the heartbeat here. So then what we'll see is this light above here. Every time that heart beats, the light moves. These are just stored memory locations that we just have a knob that we can twiddle. And then each row has an output. Call it CV, meaning control voltage. But in this case, I'm using it to control the pitch of this oscillator, the modern VCO. Again, it's going to sound a little bit harsh, but at least it will sound more musical this time. And I'll get a little bit more musical after that. Red is for audio. So now we have a basic melody. But if you notice how the volume isn't changing it, and what we can do here is put an envelope in to get it even more natural sounding. So that's done through what's called an attenuator, or a VCA, voltage controlled amplifier, which is actually an attenuator. This takes a signal in and modifies it. And you might already recognize this because this slider is also an attenuator. But it happens that this slider can go above 0, so it can actually amplify the sound. But here I can do the same thing, turn it down. Now the key is, and the power that comes from these modular systems is the control voltage, the CV. I mentioned that control voltage and volt per octave are the two most amazing aspects of modular synthesis, and particularly the East Coast style pioneered by Bob Moog. Control voltage lets me turn a knob or modify something in the system automatically using other sources. And what we're going to do is just put an envelope source here. Envelope generator. Let me think here for just a moment. Yes, we will use, it's kind of hard to see, so let me just zoom in a bit bigger. We use what's called an attack and decay by my favorite Bog Audio. So every time this clock goes, it creates like a pulse that I can use to trigger, boom, this AD envelope. You can see boom, boom, it's triggered each time, but you can see there's also a little delay between these attack and decay, because this attack goes through a full cycle that lasts 0.2 seconds, and then the decay starts. So what I do then is I use this envelope, which is a form of modulation, and I plug it in like that. I patch these together. So now it's starting to get a little more musical to where I feel comfortable turning it up back to 0. In fact, it looks like the desktop audio is kind of quiet compared to my voice. So you can see it just repeats. But let's try for some kind of counterpoint. So I just selected those and I copied them. This is something you can't do obviously in hardware. All of this. And this has 4 rows. And I mentioned this clock has multiple time signatures. So what I can do is set this second row to go at the same time signature right now, which is multiplied by 1, which is identity. And the length is only set to 1, so it's actually not going anywhere. But let's maybe set the length to 3. And I'll turn off stack for now, just for a moment, to make this more apparent what it's doing. So now I have control voltage, which I can put in the volt per octave, just like we did before. Then the output signal goes into our VCA, and the envelope is triggered by the same clock. So actually that was the wrong clock. It's same clock is on the row. Yeah, it can be. This is all optional. It's like totally a creative endeavor. Everything you do opens up more possibilities, it feels like. So now I'll put the audio out from this one to the mixer, and we'll hear what it does. So we can hear that there's a counterpoint. And for example, I don't know if this will come through, if I can pan them a little bit. And both of these are now tuned to absolute, basically, between -1 and +1. And they're independent of one another. But if I turn on stack, then this becomes absolute, and this becomes relative based on that. So it'll take the value here and subtract a certain amount of it. So it'll be sort of like moving voices together. So that means even though we only have 3 voices, all of them are relative to what's going on here. So it gives us a little more variation in the right ear. Right, let's go ahead and stack one more voice in, and I'll show you another trick. These two voices are in different ears, but in the same range, which is kind of nice. But I think it's in the utilities called the octave, and we can shift a voice. So I'm just going to, I'm going to go up. And we'll take this third one, and both these are in the same key signature, by the way. So maybe I can change that already. Interesting. I'll come back to this a bit, but it's kind of a nice phasing signal, but if I go slower, it'll make more sense, perhaps. Alright, so now our next clock is multiplied by 4. Let's check this out. This is a bit fast, but we'll go ahead and trigger our envelope. I'll just wire up the envelope first, and eventually I'm going to probably have to tweak these. But here it is. The envelope should be really fast now. It can't have such a long time because this is triggering so much faster. And 4 times clock can power this. This is an 8-length sequence, and I can run the CV out to the little octave in, audio into the envelope, the little VCA. Now we have one that's moving kind of faster, and to this 8, it sort of comes in, sort of phasing in with this other one. But if I make it 7, for example, it'll be slightly out of phase. Or I can make them all their own. But what I wanted to do is take this fast note, and usually faster things can live at a higher altitude. They move faster. You think of like birds and things. Starts to be cool. Now, a couple things we can do. One, the voices don't have to sing every note. They can kind of skip some notes. So there's a plugin for this called Bernoulli Gate. Chances is a good one. Both Bernoulli Gate and Chances are good. There's Bernoulli Switch from Venom as well. So I recommend this Count Modular set. It's really good. And Mutable Instruments, there's Audible Instruments has a few plugins. Okay, what we'll do is take this Bernoulli Gate, Chances, since it kind of explains itself a little bit better, and it takes an input signal. So we'll take this clock coming in, and we'll put it out so it goes back to the trigger. But what it does is say, okay, 100% of the time it'll go to gate A, 0% of the time gate B. So now we're basically at the same thing before, but we can decrease the probability of the voice sounding 50%. So we open up some space, and we're going to fill that space in a minute. We haven't gotten to the effects processing, but for example, same thing, we take this trigger, set the probability to 100, and then we'll back it off a bit. We'll tune this. Maybe 50% there. One more time, duplicate it. And it defaults to 50, so I'll leave it there. Two things we can do. Now add some effects and add some modulation. I think it would be most apparent if I add the modulation first. Okay. So essentially if I clear this search, we'll show you a little bit of modulation does, and I'll go to one common one called a low frequency oscillator. And there's several of these that are nice to use. Notice that a lot of the modules are for generative sound. I'm going to go a little bit smaller than this, but you get the picture. That way we can see them a little bit better. So there's some modules that are driven by months, hours, days, weeks, really long. Some of them are driven by the clock. So if I feed this project clock in here, we'll start to see it spinning. So depending on the multiplication or division, you can have a signal that changes over time. I'll show you real quick what that looks like visually. Visually on a scope. There's a bunch of scopes and visual, but let's take for example, sine wave, trigonomic function. Here we go. I can see a sine wave and start to understand, whoa, sine waves are pretty cool. Let's go a little bit faster. All this is doing is kind of like zooming it in. It's not changing the speed or anything like that. It's just making it so we can watch it. So I can use this signal though, green for modulation, to control something on this VCO. And this has what's called a modulation matrix. So you can't really see it, but now you can. This blue button, I toggle it on above this mod 1, and I can say, what do I want to modulate? Let's modulate the width between this low value and this high value using this input signal. And so we'll see in here some movement in that. And it's the same principle with this. I will just do a different division. We can use the sine wave again, plug in the mod matrix, and amount of saw and amount of pulse, but opposite direction. Notice the blue is on the right, positives on the right, negatives on the left. This one I inverted it, and heck, maybe let's do some pulse here. And I can use both of these in conjunction actually, a complex modulation. See how they interrelate with me. So we have a little bit of shifting timbre. It's all based on wave folding and sounds good. It's got a lot of harmonic content. Now that we have a little bit more space though, let's fill it with a delay. I'll leave these main ones plugged in for now, but for each of these, I'm going to output to a delay the left channel. I'm going to clock the delay so it's musical, so that it constrains, it adheres to the musical clock. And I'll put them, already we're a lot fuller, and we're half note delayed. Sounds good though. Turn the feedback down a little bit. And offset, I'll put this one on the whole note, or the quarter note, but I'm not sure what the word would be, but I'm going to put this one as like triplet or dotted. Usually dotted. Let's repeat that twice. And one thing I realized is I took the output from the wrong place. There we go. I took the output from before the VCA, so where it was a constant tone and it was really filling the space. So I need to take it post VCA, so from the VCA in other words, to the left input, and then I have stereo outputs. And this one's not on the grid yet, so let's go ahead and put that on the same grid. See the change from seconds to the grid notes. So watch, when I take this to the clock here and I let go, it's on 1 second right now. Since this one's pretty quick, let's do an experiment here with like quarter note dotted, just to hear what it sounds like. I like red for audio out. And rather than repeating it in the same ear over and over, it's going to cross, it's going to have a ping pong. So now we have these dancing melodies. I haven't even done much percussion, but even if I take off the stacking now, it becomes more regular, but still a lot of randomness because of the chants we've introduced. One thing we can do to smooth out the whole signal and give it a sense of space is reverb. Omri Cohen says reverb is live, and two of my favorite reverbs, I guess, is just the surge, which is actually 2, but this plateau. And we'll go ahead and use this plateau on the auxiliary send. So how this works is send goes out to the input of the plugin from left and right channel, and then the plugin returns it from the plugin output to the return value. Left return, right return. Now this is designed so that it will enhance the sound. So we don't need the actually original sound, we just want the wet sound. But due to the nature of this plateau, I'm not going to put the wet level at 100 because it kind of gets a little bit runaway. So then now that we've got this wired up, we can actually use it. So we got A, B, C, and then we'll call this A, delay, AD, B, delay, C, delay. When I give these names, then it makes it easier for me to kind of see what I'm editing here. So guys, C, delay, and then I can take the red auxiliary, there's red, orange, blue, and purple, and I can slowly feed it in. Really big space, small space. Make the space small, then open up the delay again. So we're in like a small room, but the reverb is just intense, almost pure reverb there. Medium-sized room, you can hear the room get big right there. Sometimes we get a lot of high, so we'll take a little bit of high and maybe cut out the low. And put it on a relatively good value, but you gotta just sort of explore the sound there. And then we want to make it minor. Minor. Or suspended. Make it a whole tone. Change the tonality around a bit, in and out of balance, I guess, harmonic balance, have some dissonance. Okay, let's let this run for a little bit. And this is what I would consider generative music, mainly due to the introduction of chants. But it might be nice to have a little bit of a rhythm. So here's an idea. We'll put an a sequencer here with just a nice drum rhythm. Kick on. For example, with this multiplied by 4 clock that I can run directly in. And I will use it as a trigger for our bass drum, and I will put the output there. Sorry, not multiplied by 4, but that's interesting. And for a simple one, actually, let's use this oscillator. It's really relaxing. And we'll use one called Palette. It has this nice set of percussive oscillators as well as tonal oscillators. And this one can run at the 4 times clock. Let's just pop that in there. Gate. We will trigger it. Trigger input here, and I will put the output mix to a ringer. It's not ringer. It's an SVG interface, which I started to use earlier. I mentioned it earlier. There we go. So it's giving me that nice choke. Lots of modulation here. So now we sort of get that idea. What I want to do with the modulator. So some of that was just low frequency oscillator. And it could be that they run at different frequencies, though, is the thing. I haven't really found one that's... These give me at different intervals, but they're at the same frequency. Nonetheless, we can do that here with quad LFO, for example. So this goes 4 oscillators at controllable phase angles. So I can put a modulator here on the filter and attenuate it. something like that. So like essentially it's this up here. And if I can reuse this one for sawtooth output modulating all the way down to the decay. So we kind of get that. I think we can have some chance on the hat as well, right? It's nice, but more often. But one thing we can do first, sometimes you'll I couldn't get this one to work. I've tried this one. I was doing something wrong. Well, let me try it. So if I get it like all of our clocks are busy, but since this is a multiple of 1, I'll just put it at the main clock and I can multiply this by like 11. So we'll drive this burst generator with a multiple of 11 clock. Let's see if I can get this to work. And I think the external clock goes here, right? Because the labels are above, so external clock goes here. So that means that when we get a trigger, so when I trigger this this is another thing we need is a trigger. These are all multiple. I don't need to go all the time. But one thing I do is, again, with chance, give it a really low chance. And this is my slowest BPM. So it'll be basically random, but a really low. Well, let's just get it up here real quick so I hear it. And we'll use this as a trigger. Clock trigger gate, and it'll trigger this. This didn't work out how I thought. So I can add. Well, it's essentially a mixer, a CV mixer. Mixes 6 signals. Or CV mix. Should be the same. So basically, I'll either get pulses or the. Let's see. There we go. We start to mix it up a bit. Just add a little flam every once in a while. I don't know if it'll sound good. It's more subtle. One thing I haven't really used is filters. These are all just kind of doing their own thing. So on my way to the mixer, I can add a bit of filtering. Just move this all over. It's either surge or bog audio. I don't know. They're both so good. Let's do a little bit of both. I wonder if I should do this one also. Post filter. Let's check it out. This could come up a little bit higher. I think it's quiet. Thank you for a second. Let's do this. One I haven't introduced is walk. This is a low frequency oscillator, but it uses Brownian noise, I think, so that it's always connected but moving randomly. At every moment it makes a decision about which direction to walk. It's sort of like a foraging animal. So it's kind of cool. And I get X and Y, so you get Cartesian coordinate systems. You get 2 outputs. So I can use this to drive, for example, the CV, and it'll walk filter up and down based on the value. So let's make it move a little bit faster. Now the other one I can use for something else. I don't know what, but sometimes I like a little bit of modulation. This is a bit dangerous, but on the delay, let's see if it works. Might not. No, it didn't quite work, did it? Let's take that off of there. Pretty cool stuff. So now we have these extras. We've got kick, which is just giving us a drive, and then sort of hats. And I'll put some reverb in the hat. And maybe a bit of kick, but we don't want it to be too muddy. Yeah, maybe we could use one of these to add a little bit of modulation on the decay, so kind of an accent, kind of tune it a little bit as well. So you kind of get the idea. Looks like we're compiling as well. So yeah, it's almost 9 p.m. I'm getting a little bit tired, but it looks like we successfully were able to compile Rack today. We mined a nice little piece, and I don't know if I'll converge these two paths of open source development and music creation into a single channel. This is a bit of a insight into what it's like to work with VCV Rack at the very least. Very cool. So yeah, it's fun stuff. I think it feels therapeutic to me. It's very relaxing. Yeah, so thanks for checking it out. Thanks for stopping by. I hope in another live code session we'll be digging a bit into the C++ code for developing our own Rack modules. Now today we were able to get Rack compiled, and now we can use a generator function to generate a hello world function. I'll do that in another session. So again, thanks for stopping by. I hope you're doing well, and have a great day.